I always thought resolution wasn't really a big deal. That is until today. While testing the LTX 2.3 custom audio workflow, I had to admit that even the smallest issue can completely throw you off track. Initially, the entire testing process was going really smoothly. I successfully completed tests for single character custom audio and multi-character custom audio, and the results were absolutely fantastic. That was until I uploaded this particular image. Suddenly, the previously flawless workflow ran into a problem. The character had body movements, but the lips weren't moving at all. So I tried to figure out exactly where the problem was. I made a lot of guesses. I thought the most likely culprit was the camera angle, because the image I uploaded wasn't a straight-on frontal shot. But I quickly ruled out that guess, because in the tests I had already done, many of them weren't frontal shots either, yet I still got great results. After running all sorts of tests, I finally pinpointed that the issue was actually with the resolution. Now let me tell you the tragic story of what I went through. With previous video generation models, there were only two core elements, the prompt and the reference image. But the LTX model is different because it can generate audio simultaneously. Therefore, its core elements have increased from 2 to 3, adding audio into the mix. In our previous videos, we already covered text to video and image to video. So inevitably, we needed to explore audio to video generation. How exactly do we build this workflow? It is actually quite simple to make testing easier. I deployed this workflow on Running Hub. In the ComfyUI space, Running Hub is an incredible online cloud platform because whenever new models or technologies emerge, they are always the first to support them. Running Hub also provides a fantastic online community for ComfyUI creators, where you can find tons of inspiration and practical workflows. Below, I'll show you several workflows, but keep in mind that they essentially boil down to two types, single character custom audio and multi-character custom audio. Of course, due to computing power constraints, we can't design a scene with too many characters, so I'll be using 2 characters for the custom audio test. First, let's look at single character custom audio. When we introduced the LTX 2.3 model before, we used 3 workflows, the native ComfyUI workflow, the one provided by Kijai, and the Guff workflow. I highly recommend using Kijai's workflow because based on my test results, it is relatively more stable. If we want the generated video's audio to be one we provide rather than randomly generated, that is the core requirement of custom audio. In the original workflow, before sampling, we generated an empty audio latent, and we could only use the prompt to constrain the basic nature of the generated sound. The core trick to using custom audio is replacing that empty latent. First, we upload an audio clip.
Okay, yeah. I resent you. I love you. I respect you.
Here, we need a crucial node to trim a section from the audio to use as our reference. The next question is exactly how long of a section should we trim? We need to calculate this. First, our total frame count is set to 121 frames, and our frame rate is 24 frames per second. With this, we can calculate the total duration of the video. You must trim the audio according to this total duration. After trimming, we need to process the audio, specifically vocal isolation. There are generally 2 types of audio we might use, spoken words or singing. If it is a singing audio track, we must separate the background music from the vocals. This is where we use these 2 nodes. These nodes actually come from a ComfyUI extension provided by Kijai. You can find all the model download links and specific usage instructions for each node on his GitHub page. Once we extract the vocals, we need to use the LTX audio encoder to encode this sound. This will give us an audio latent. Next, we need to generate a mask. This mask isn't much different from an image mask. The only thing to note is that the width and height of the mask must exactly match the resolution we've set, and the color should be set to black because, as we all know, black in a mask represents an uneditable area. Then we use the set latent mask node to apply this black mask to our audio latent. This operation essentially locks the audio in place, preventing the model from modifying it. This ensures the integrity of our final audio. The generated latent is then combined with our video latent. Finally, this combined data is passed to our sampler for sampling. The rest of the workflow is basically identical to what we discussed before. In the first test workflow, the image I selected was a straight-on frontal shot, and the audio I chose was a 4-second English clip. After running it, I got a very good result.
Okay, yeah. I resent you. I love you. I respect you.
Because I felt the frontal angle was too rigid, I then selected an image of a beautiful woman from a side profile. This time, I set the resolution to a 3:4 aspect ratio, which is 960 by 1280, but the result I got only had body movements. Her lips didn't move at all. At the time, I thought it might be because it was a side profile image. I ran many tests until, by chance, I changed the resolution to 720 by 1280. And then a magical thing happened.
Yeah. I resent you. I love you. I respect you.
Under the 916 resolution, I found that no matter how I changed the camera angle, the results were perfect. Here are two very typical tests. For example, this reference image shows a beautiful woman drinking coffee in a cafe, and the camera angle is a top-down view. Overall, this is a pretty tricky angle. We use the same audio. You can keep the prompt simple. Here, I wrote, "A beautiful woman is talking." Then I set the resolution to 720 by 1280. Let's look at the final generated result.
Okay, yeah. I resent you. I love you. I respect you.
The overall lip syncing accuracy and video quality are extremely high. Then I increased the difficulty again. I used a rather uncommon angle here, a back view shot. The characteristic of this angle is that we shoot the character from behind, and the character needs to perform an action of turning her head to look at the camera. We used the same audio, the same prompt, the same resolution, and even the same seed. The result I generated was also fantastic.
Okay, yeah. I resent you. I love you. I respect you.
After multiple tests, I've concluded that if you want to reliably generate a high-quality custom audio video on the first try, you should try your best to set the video resolution to either 16:9 or 9:16. Other resolutions might have some issues to varying degrees. Many people might wonder, is 16:9 more stable, or is 9:16 more stable? I can tell you for sure, 16:9 is more stable, because if you remember ComfyUI's official introduction of the LTX 2.3 model, they explicitly stated this model offers better support for vertical, meaning 9:16 resolution. Therefore, we can be certain that 16:9 is still the more stable baseline. Now that we've achieved single character custom audio, let's look at how to pull this off with multiple characters here. I strongly recommend using a 16:9 resolution, because we inevitably need to fit two characters into this scene. Take a look at my reference image. It is a boy and a girl having a conversation in a classroom. To clearly show you the effect of multi-character custom audio, I uploaded the boys and the girls audio tracks separately.
我其实不太会喝酒。
Oh wow, my mortal enemy Mr. Thompson's problem sets.
Furthermore, I used the audio contact node to link them together. What is even more interesting is that the boys' audio here is in Chinese, while the girls' audio is in English. Once the audio is combined, the rest of the processing is exactly the same as the single character custom audio workflow. If you remember, when we did multi-character custom audio in models like Infinite Talk, we needed to attach a mask to help the model determine exactly who was speaking at any given moment. But clearly, LTX doesn't have that feature. So how do we define the speaking order and duration? At this point, we have to rely entirely on the prompt. Therefore, the core of multi-character custom audio in LTX 2.3 lies entirely in how you write the prompt. Let's first look at my prompt, and then we'll summarize the rules behind writing it. My prompt goes like this: automatically assign two male and female voices to speak based on timbre. The boy speaks first, and the girl speaks afterward. And I explicitly state that the girl's speaking time is from 4 to 8 seconds. Let's break down this prompt in detail. First, I explicitly stated the audio composition, writing two male and female voices. Also, the speaking order and duration must be clearly defined in the prompt. The boy speaks first. We don't need to write the duration here because it obviously starts at 0 seconds. But for the girl speaking afterwards, we must provide a detailed annotation. The girl's speaking time starts at the 4th second and ends at the 8th second. There is another crucial setting here, the total frame count, since I currently have an 8-second video, and the frame rate is 24 frames per second. My total frame count should be 192 frames. However, the total frame count must be a multiple of 8 plus 1. So I set it to 193 here. After sampling, let's look at the generated result.
我其实不太会喝酒。
Oh wow, my mortal enemy Mr. Thompson's problem.
You'll find that the effect is absolutely fantastic. Because my resolution is 16:9, there are no rendering errors. At the same time, we've also verified that LTX 2.3 is a multi-language generation model. It supports both Chinese and English. Of course, it should support other languages as well. In our test, we mixed Chinese and English, and as you can see, there were absolutely no issues. Careful viewers might have noticed that this audio processing technique is actually exactly the same as in LTX 2.0. We just need to pay attention to the fact that there might be some differences in the performance of custom audio under different resolutions. Additionally, when dealing with multi-character custom audio, we must clearly spell out the voice composition, the speaking order, and the duration within the prompt. Alright, that is all for today. What are you waiting for? Go try it out yourself. Follow me to become someone who truly understands AI.